Hello friends, welcome to Electronic Circuit Hub. So today we are going to understand about one important topic from operational amplifier, that is input offset voltage. Okay, it plays a vital role in Opamp circuit design. Okay, so this input offset voltage is a very critical in the analog circuit design where the Opamp is being used. Okay, so we'll see in the data sheet how it is defined, how how we can understand this chart, okay, this graph, right? So if you go and look the data sheet of this operational amplifier, what is the name of this operational amplifier? This is MCP6001, right? So if you go and look the data sheet, this is obviously a data sheet. So if you go and look the input offset voltage, let me show you somewhere here. Maybe it is defined as, right? So the input offset voltage is here, you can find. So it is given input offset voltage is VOS, which is defined minus 4.5 volt plus minus 4.5 millivolt to plus 4.5 millivolt, and the condition they have given, the common mode voltage equals to the VSS voltage, right? So basically we oftenly look this terminology. There is an input offset voltage and which is given by VOS, and it is minus 4.5 to plus 4.5 millivolt, and it has also given the input offset drift with temperature, which is given by plus minus 2 microvolt per degree centigrade. So we are oftenly, what we do is we look this parameter and we assume that our parts which we are going to buy in the manufacturing or production will fall under this range, that is minus 4.5 to plus 4.5. Okay, right? So basically, while we design our circuit by using operational amplifier, we assume this is the, yes, obviously this is the worst case and this is the maximum offset voltage which a data sheet states. Okay, so our objective here to understand today the graph between input of offset voltage and the occurrence, right? So our intention here today to understand this graph. This is given a graph is input offset voltage and the percentage of occurrence. So input offset voltage is given in x-axis and in y-axis you can see percentage of occurrence. Okay, so number of samples for to plot this graph is 64,695, right? So the number of samples which was tested to plot this graph is 64,695, and you can see there they have given 0, 1, 2, 3, 4 and 5, and this side they have given minus 1, minus 2, minus 3, minus 4 and minus 5. Okay, so it could be minus 5, maybe there is some clerical mistake here. So you can see here 0. If you go this and if you assume this, you can see your 18% samples you buy will have 0 offset voltage, 0 millivolt offset voltage. So the number of samples which falls under 0 offset voltage is 18%. Now if you go this side, from, let's say, 0 to 1, you can find from here between 0.5 the number of samples which falls under plus 0.5 millivolt offset voltage is 14%, and here you assume 1, so you can find is around 9% samples falls 1 millivolt offset voltage, and here you can see 1.5, so your 4% sample falls plus 1.5. Here you can see 2, so around your 1% sample falls under 2 millivolt offset voltage, and likewise you can see here around this is, let's say, 3.5, and you have around very less, even 0.1% samples falls around 3.5 millivolt offset voltage, and you can see at 4.5 you don't have any person any samples. So you can see here, even they have stated the offset voltage minus 4.5 to plus 4.5 millivolt, but here you can see your maximum offset voltage which you can achieve is 3.5 plus 3.5, and where you can see the number of samples is very less, around 0.1%. Now let us talk about minus offset voltage or negative offset voltage. So here is a 0. Here let's say we have this window, this is 0.5 minus 0.5, and you can see your 19% samples falls against this minus 0.5. Let us assume this is 1, so your 15% samples falls under minus 1 millivolt. Your let us, this is minus 1.5, your 10% sample falls under minus 1.5. Now you can see here, you come here and between this is minus 3.5, and you can see here around 0.1 or 0.2% of sample falls under this offset voltage. Now you can see this is minus 4, and they have, if you zoom it, you can see they have given some here, maybe some samples also falls under this like minus 4 millivolt offset voltage. So you can see one thing here, your negative side is offset voltage is more than your positive side. So here in your positive side you have the offset voltage is plus 3.5, let's say, but at the negative side you have offset voltage is minus 4 millivolt. Okay, so this is the plot between input offset voltage and percentage of occurrence, and you can see another plot which they have given the input offset voltage drift and the percentage of occurrence. This could be also a similar plot. So hope you have understood how will you read the data sheet for Opamp, data sheet of Opamp for input offset voltage, and how you predict what is going to be happen in your production, right? What is going to be happen in production, and what tolerance analysis you need to do, and what variability you need to analyze in for the production. Okay, and what process capability you build up to accommodate this variability, right?